Now let's continue with more examples for section 2.3. So first, let's see some direct evaluation by continuity. So notice these two examples. We have limit when x goes to 0 of cosine of x. So in this case, we have that cosine of x is a continuous function. So this is going to be cosine of 0, which notice is just f of 0, and in this case that's 1. So that's going to be the result we're solving here. Now for the second limit, notice that this is a little bit more complex. This is when x goes to 4, and so on top is you're gonna get a 16. And on the bottom, you get 5 by 4 is 20 plus 5, 25. Square root of 25 is 5. 5 minus 1 is 4. So you don't really get any issues. So this is also continuity case. We can say, well, this is going to be the same that f of 4, which is 4 times 4. Over square root of 25 minus 1, and that's 16 over 5 minus 1, or 16 over 4, okay, which is 4. So simple enough. There's not a lot to say in this scenario. We don't have discontinuity, so we can just plug directly using the function. Notice that we can also work this one out using properties of the limits, because since the bottom is not 0, then I can split this apart in these two limits, and so easily you can see that this part is just going to be 16, and in this part this is also continuous without issues. Square root of 25 minus 1. 16 over 4, 4. Okay, so no difference here. So now let's take a look at what happens if instead of getting the function, we get the values of the limit. In that case, we can also use the values that are given. So in this problem here, we're assuming that limits when x goes to 3 of f of x is 39. Limit when x goes to 2 of when x goes to 3 of g of x is 9, and when x goes to 3 of h of x is 6. So it says find the following limit and state the limit law that you use. So clearly, as you can see here, we have a quotient and we have a subtraction here. The bottom g of x goes to 9 when x goes to 3. And h goes to 6, so I don't anticipate that this is going to become 0, and so I can split this in a quotient of limits. I can split this in this, and this is by quotient rule of limits. And then I can further split this as limit when x goes to 3 of f of x, and limit when x goes to 3 of g of x minus limit when x goes to 3 of h of x. And from here to here, what I'm using is the subtraction rule for limits. Okay. So more of the properties that we previously discussed. And this is 39 on the top, and this is 9 minus 6. So 39 over 3, that's going to be 13. Right? So this is pretty much another example of using properties of the limits. So now let's move to another couple of examples. So first, Notice that this limit that we have on top here is one of those limits that is from the form 0 over 0. Why? This is limit when x goes to 1 of a square root of x minus 1 over x minus 1. In both cases, a square root of 1 is 1, 1 minus 1 is 0, and 1 minus 1 is here at the bottom. We can, since this is the form 0 over 0, we can probably guess that that's not the real value of the limit. And so what we do is we're going to use algebraic trick with the bottom, and we're going to factor that out. So notice this is the trick. I'm going to consider that x is just a square root of x squared. Okay? And I can consider that 1 is also 1 squared. Since this is x, as you can see, and 1 squared is 1. But now this here is a difference of squares. And so this term is going to show up again. So now this is limit when x goes to 1 of square root of x minus 1 over square root of x minus 1 square root of x plus 1. And so notice now I have the same term up and below, and I get to cancel that term, and I can just write this limit as limit when x goes to 1 of 1 square root of x plus 1. Now this is a continuous function, it has no issue below, and I can say, well, this is going to be just 1/2. And so that's the end for that particular limit. This technique is factoring in a difference of squares. But we can do something similar, which is actually based on the same rule of the difference of squares, which is this one. And that technique is going to be the opposite. Instead of factoring, we're going to multiply by whatever we're missing to get to this square. And so this is the example here, example D. Notice that I can write this limit when t goes to 0 of t 3 plus square root of t minus the square root of 3. Notice that if I plug the 0, this is again from the form 0 over 0. So that's what it's telling me that probably I need to do something else. Now what I'll do here is notice that I have this term minus this term. So I cannot have this part. So I need this part so I can get rid of the roots. So that's what we're going to multiply. So we're going to multiply up and down for the same thing. So a square root of 3 plus t plus a square root of 3 up and down. So it's a 1. When we're multiplying by exactly the same thing, this is essentially multiplying by 1. But this produces the effect that there's a difference of squares now. This with this is going to produce something new. And so now in the top I have t3 plus t plus a square root of 3. And on the bottom, now I have 3 plus t, which is the square of the square root of 3 plus t minus 3. And so notice that I get to cancel now the 3. And I'm only missing, only left with the t. So this is limit when t goes to 0 of t 3 plus t plus the square root of 3 over another t. So now I can cancel out this t, and the only remainder is going to be the sum of those roots on top. And so if I plug in 0, I'm going to get square root of 3 plus the square root of 3, so 2 square root of 3. Okay? And that's the end of this particular example.